A 15 molar solution of an acid has a Ka, so we have 15 molar, that's describing concentration, and we have the Ka 7.5 times 10 to the negative 3, and that's going to describe the strength of the acid. Give you a little more detail. 15 molar, what is that saying? Molar is a unit of concentration. What that means is there's 15 moles, that's Avogadro's number, that's 6.022 times 10 to the 23rd. This is a very concentrated solution. That's how many moles you have in a liter. You have a lot of this stuff in a little amount of space. The strength is described by the equilibrium position of this weak acid. We can write that equation as generically as HA, where A is the acid and H is the proton that the acid is going to lose, because that's what acids do. Now put that in water, and immediately it's going to increase the concentration of hydronium ion. They'll lose a proton and water will accept it, and that makes water the base in this case. And then you'll have the conjugate base as well. But at some point equilibrium will be reached, and for weak acids the equilibrium lies far to the left, so less than 5% actually ionizes. So these are the ions from that weak acid. We also say it dissociates, and you can have a lot of this acid. That's the concentration. You can have a lot of moles in per liter, but that is not actually, the more you have, the less this is going to dissociate. So you're going to have very little bit of it actually ionizing. So that's what makes this a weak acid. A common misconception is students will sometimes think a strong acid is always dangerous and a weak acid is always safe or something along those lines. And that's not true. A very common weak acid we bring up in class is acetic acid. That's vinegar has about 6% or so acetic acid. That's CH3COOH. And you put that on your salad dressing. But if you had not 6%, but if you had like 100%, that would be a pretty deadly stuff. Or even, here's another weak acid that's also deadly is HF, hydrofluoric acid. So weak acids don't mean safe. Vice versa, if you have a strong acid and it's not concentrated, so you can have like a hydrochloric acid or sulfuric acid and put one drop of it in a lake or something like that, nobody would consider that dangerous, even though that's a strong acid. Right, because it's so dilute. So when you talk about things that are dangerous or not, consider the concentration of that solution. The short of it is concentration and strength refer to two different characteristics of acid-base solutions.